my name is Megan Sell, and what I'm going to be talking about, as I state in our objectives, we're going to use nets and three-dimensional figures to find surface area of cubes and prisms. One thing I'm going to start with is asking a good question. What real-world activities, or what are some real-world activities that we can use surface area to solve problems for? And I'm going to talk about that at the very end, but as we go throughout this, maybe you can kind of think of some. So first I'm going to look at a net. What a net is a two-dimensional shape of a solid. In this case, this is a net of a cube. To find the surface area of a net, we have to take each part of the net, in this case, which are squares, and we've got to find the area of each part. So what I did is I measured our net, the actual net, and I just kind of blew it up a little bit, and I measured each side to be 6 centimeters. So we've got to find the area of each of these squares. Well, all of them, they're going to all be equal squares, so I know they're all going to have the same area. So if we take 6 centimeters times 6 centimeters, that's 36 centimeters squared. So if this is 36 centimeters, I know this is also going to be a 6 by 6. So that's going to be 36 centimeters. And same with this, same with this, same with this, and same with this. Because on a cube, every single side is the equal square. It's got the same area. So what I'm going to do is to find the total surface area of this net as well as that three-dimensional figure. I'm going to add each of these parts up. So I take 36 and I'm going to multiply it by 1, 2, 3, 4, 5, and 6, because that's how many faces this figure has. 36 times 6 is 36. 6 times 3 is 18, plus 8 plus 3 is 21. So our total surface area of this cube is 216 centimeters squared. What we can do is we can apply this same principle, or these same steps, to a rectangular prism. The reason why it's a rectangular prism is because the base is in the shape of a rectangle. And so if we sat this on the ground, that would be considered our base. So what we're going to do is we're going to find the total surface area of this three-dimensional figure. If I cut this out, I can make a net from it. But since it's three-dimensional, we're going to try and use this. We're going to try and use this to find total surface area. So what I'm going to do is I'm going to start with the top. The top of the figure is going to be opposite the base. It's going to be parallel to the base. And what I did is when I measured your length, which I made this my length and this my width. Because I like to keep length the long side, width I like to make the short side. So my length when I measured it was 28 centimeters squared. Because I measured it in centimeters. You can do it in inches, but in my opinion, centimeters in this case was a lot easier to work with. So my length was 28 centimeters. My width was 21 centimeters. So now we've got to find the area of this part of the three-dimensional figure, the rectangular prism. So I'm going to take, because we know area of a rectangle is length times width, I'm going to take 28 times 21, and that gave me 588 centimeters squared. I'm going to box that. Now, I know this is 588 centimeters squared, so if this side is that much area, then the side that's parallel or opposite to it, which is going to be the bottom, is going to have the same area as well. So I know that this is also going to be 588 centimeters squared, because our length here is 28 and our width here is 21. They're the same dimensions. So now we got the top and the bottom. That's 2 we have found. Now I'm going to start with the front. The height, which is going to be that part, because when you sit this down, the height gives that three-dimensional look. I measured that and I got 3.5 centimeters. If this is 3.5 centimeters, then I'm looking at my length, which, as we found up here, is 28 centimeters. So we got 3.5 and 28. Same, it's a rectangle just like it was with the top, it's just different dimensions. So I'm going to take 28 times 3.5, and when I did that, I got 98 centimeters squared. So 98 centimeters squared is for this front part, because it's 28 by 3.5. The back is going to be the same dimensions. You're going to have 3.5 and 28 because this is your length, this is your height. So that's 98 centimeters squared as well. Now I've got 4 of the 6. The last one is going to be this side. I know my height is 3.5 centimeters. My width is going to be this part, which is 21. So 21 times 3.5 I found out to be was 73.5 centimeters squared. So if this is 73.5 centimeters squared, this is going to be 73.5 centimeters squared. So now I've got all 6 faces of this figure done. I found out the area of all of them. So what we're going to do is we're going to take the top and the bottom, which is 588, we're going to multiply it by 2. That gives me 1176. So that's the area of the first one. Next one, I'm going to take the 98 and I'm going to multiply it by 2. That's 196 centimeters squared. On the side, we're going to take 73.5 and multiply it by 2. That's 147. So now if we took all of these sides and we added them up, that's 1,519 or 1,519. So now I know this is my total surface area. So let's think back to that guiding question I was talking about. When you're using surface area, what is something we can use in the real world to use the surface area of a figure to solve it? One way is if you look at this board, the wall up here is painting a surface. If you know the dimensions of the wall, you can find out how much paint you're going to use. Another way is by wrapping a present. So if you wrap this present, you can find out how much wrapping paper you will need. So now what I want you to do is I want you to go out and I want you to figure out how much surface area you have on the presents you wrap for Christmas. Thank you and hope you enjoyed this.